Alright, so you know how to figure out the polarity of specific bonds between two atoms. Now we're going to figure out the polarity of an entire molecule. So, as you know, a molecule is just a combination of bonds. So to figure out if a molecule is polar in itself, or if the whole molecule is polar, what we have to do is we have to look at the overall pull of electrons on all the individual bonds in that molecule. And if there's a certain direction, one way or the other, then we say that molecule is polar. And what we mean by polar means that the molecule has a definite positively charged, partial positively charged side and a negatively charged side. So to do that, we'll look at a couple examples of nonpolar and polar molecules. All right, so these two molecules here, CO2 and BH3, those are nonpolar molecules. Now to figure this out, what you want to look at is you'll look at each individual bond and see the direction of electron pull. So if we look here between this oxygen and this carbon, between oxygen and carbon, oxygen's more electronegative. So the electrons can be pulled in that direction, which is what I have down here. Okay, on this side, between carbon and oxygen, again, oxygen has more electronegativity than carbon, so electrons are getting pulled that way. So in a sense, the electrons are getting pulled in opposite directions. Okay, so opposite directions, opposite pull of electrons, and they basically cancel out. So therefore it is non-polar. All right, so just think of playing tug of war, two equal strength people doing tug of war, pulling opposite directions. They just stand there, nothing happens. That's what a nonpolar molecule is. All right, so here's BH3, same thing here. Between boron and hydrogen, which is all of these, boron is more electronegative. So all the electrons are getting pulled in here, and all of them cancel each other out. So since they cancel each other out, again, that makes it not polar. Right? You don't have any direction where the electrons are getting pulled to, so you're not getting a definite negative direction and a definite positive direction. So those two are nonpolar. Now here's what a couple polar molecules look like. So here we go. So water is a polar molecule. So if you look at this, all right, here's hydrogen and here's oxygen. Oxygen's more electronegative, so it's pulling the electrons from hydrogen to oxygen. Same thing on this side. The oxygen's pulling the electrons away from hydrogen there. Now if you notice by the direction of arrows, there's a general direction that the electrons are getting pulled towards, and that's towards the oxygen. So this symbol right here, say it's an overall pull of electrons from the hydrogen to the oxygen. So what that means is, since the electrons are getting overall pulled towards the oxygen is your partial negative end, and your hydrogens are your partial positive end. So water is a polar molecule, negative on the oxygen side, positive on the hydrogen. All right, same thing down here with NH3. Nitrogen is more electronegative than the hydrogens. So you have an overall direction. All of the electrons are going in one direction there, which is towards the nitrogen. So your nitrogen is a partial negative end, and your three hydrogens, partial positive end. So again, that's a polar molecule. As you can see, like on the other two molecules, the electrons are getting pulled in all different directions. There is no definite negative end, no definite positive end. Here, you have them. Now, another way to do this is something called the line test. So, what we mean by the line test is, in your molecule, if you can draw a line anywhere in the molecule, and you can separate the negative ends from the positive ends, you have a polar molecule. say if we do water again, I'll draw this over here. All right, oxygen we said is our partial negative, and each hydrogen's a partial positive. So if I take a line, if I draw a line right here in the middle, as you see, I draw the line here, I separate the negative half from the positive half. That means I got a polar molecule. Now it doesn't matter that it's symmetrical, it doesn't have to be. Okay, you can have oxygen on top, hydrogen on the bottom, it doesn't matter. It does not have to be symmetrical, just if you can separate the two, that tells you it's polar or not. Same thing with NH3. All right, so with NH3, partial positive, partial positive, partial positive, partial negative, and again, draw the line right there, negative end on top, and a positive end on bottom. There you have it, polar molecules using the line test. Now, check out these two here, these are non-polar molecules. Can't do any line tests here, can you? If I do that, not going to work. Line right there, nope, negatives on both ends, so can't do it. All right, same thing here, a line here, nope, positives on both sides. Line here, nope, positives on both sides. Okay, and it has to be a straight line, so you can't do something like that. That's not a straight line, that's a circle. We learned those in geometry. All right, so there you go. So that's your polar molecules and your non-polar molecules. A couple other examples to show you here. So here's methane, CH4. So carbon, hydrogen, hydrogen, and also figure out polarity. You want to do the shape of the molecule, the Vesper shape. Lewis stat structure, not always accurate. All right, so think about it. Is this a polar molecule? Correct, it is not a polar molecule. All right, so the carbon is more electronegative because that's further to the right than hydrogen. So that's your negative, positive, positive, positive. So all the hydrogens are partial positives. No straight line's going to work there, right? Methane is non-polar. All right, now methyl chloride. Yeah, let's check this one out. So methyl chloride, same thing as methane, except they took off one hydrogen and threw on a chlorine. Now this will work whichever spot you put the chlorine in. So I just stuck it here because I made it last. All right, so between carbon and hydrogen, we did this before. Carbon and hydrogen, carbon's the more electronegative. So you got these going on here. Okay. But now let's look between carbon and chlorine. Chlorine's more electronegative. So that's going to pull the electrons away from carbon. So that's going to be a partial negative. Now that's a positive there. Now notice with carbon, C is both positive or partial positive and partial negative. If that happens on the center atom where they're partial positive and partial negative, you can basically just say they cancel out because the electrons are being pulled from them and it is pulling. The carbon's pulling the electrons and the electrons getting pulled. So they're kind of doing both, so we can count as canceling them out. So I'm just going to erase those just to make it a little clearer since those don't count. All right, now we do our line test. Let's check this out. We do a line somewhere? I think we can. I'm going to put that line right here. And again, doesn't matter. Doesn't have to be symmetrical. Doesn't matter how many atoms are on which side of the line. We don't care. As long as you can get the positives on one end, which you have here. Here's your whole positive end on this side. And your negative ends on there. So there you go. So methyl chloride is a polar molecule. There we go. All right, and we'll do one more so you see this here. HCN, hydrogen cyanide. So carbon has 4 bonding sites. Okay, we're going to stick a hydrogen here. Nitrogen has 5 valence electrons. So I'll write that a little better. 1, 2, 3, 4, 5. So hopefully you should be able to tell that those are going to hook up. So we got this. All right, so let's see, is that polar? All right, let's check it out. Between hydrogen and carbon, carbon's more electronegative. So there's your partial negative, partial positive. Between carbon and nitrogen, nitrogen's more electronegative. There are negative and positive carbons, those cancel out. So we got definite positive end, definite negative end, right? Here's your positive end right here. And there's your negative end. So HCN is a polar molecule. So that's how you figure out molecular polarity. And the line test is an easy way to do it. So just figure out which ones are partial positives, which ones are partial negatives. If a central atom's doing both, cancel it out. Right? And yeah, it doesn't matter that it's being a partial positive for 3 atoms, but partial negative for 1 or vice versa. That doesn't matter. If it's doing both, again, pulling electrons and getting electrons pulled from them, you can just cancel them out, just ignore them. So that is your molecular polarity.